This lecture, we are going to see the topic that is related to the degree of static and kinematic indeterminacy of beams, frames, as well as your trusses. Now coming to the contents part. So here, these are some of the contents we are going to discuss in this lecture. So first we are going to see what the statically determinate structure is, and then what is a indeterminate structure, then what is the indeterminacy of a structure, what do you mean by indeterminacy, and then you're going to differentiate between the static and kinematic indeterminacy, and then degree of indeterminacy, you're going to take an example for a beam and you're going to solve, and then degree of static indeterminacy for a pin jointed trusses, and similarly degree of static indeterminacy for a rigid jointed frame. Similarly, for the kinematic indeterminacy, we are going to see for a pin jointed trusses as well as a rigid jointed frames. Now coming to the statically determinate structure. So when we can call any structural system to be a statically determinate. So statically determinate is nothing but any structural system that can be analyzed using only the equations of static equilibrium. That means your reaction components and internal stress components can be calculated by using only the static equilibrium conditions. So then you can call the structure to be a statically determinate structure. And here you can see some of the examples like cantilever beam, and then simply supported beam, and then simple Warren truss, and then cantilever bent frame. So here, whatever the reactions that you are getting, so those reactions or unknowns you can call. So these can be solved by using the static equilibrium conditions. So this is your statically determinate structures. Now coming to the next one, that is statically indeterminate structures. So the structures which cannot be analyzed only by using the static equilibrium conditions alone. So then the structures are called as statically indeterminate structures. Now you can see the examples like proper cantilever beam, fixed beam, and portal frames, then Warren truss, and next continuous beam. So here, whatever the unknowns you are getting, so there are more when compared to the static equilibrium conditions. So you cannot solve by using only the static equilibrium conditions. So that is the reason these all structures are considered as a statically indeterminate structures. Now coming to the indeterminacy of structures. So indeterminacy can be divided into two types. One will be static indeterminacy and another will be a kinematic indeterminacy. So in static, again, you are having a two types, that is external indeterminacy and internal indeterminacy. Now in detail, we'll just see what do you mean by a degree of static indeterminacy and degree of kinematic indeterminacy. So coming to the static indeterminacy, so in the static, we have a number of redundant forces. That means static indeterminacy will talks about the redundant forces or the reactions, whatever that can't be found only by using a static equilibrium conditions alone. Whereas degree of kinematic indeterminacy is nothing but it is the number of movements of a joint, if you just consider. That means we can call this as a degree of freedom also, with which the kinematic configuration of overall structure can be defined. So here the unknowns are nothing but your independent movements of the structure, whereas in the static indeterminacy, the unknowns are related to the redundant forces. So this is denoted, degree of static indeterminacy, it is denoted by ds, whereas degree of kinematic indeterminacy, it is denoted by dk. And this degree of static indeterminacy is also known as degree of redundancy, whereas this degree of kinematic indeterminacy is also known as degree of freedom. And this static indeterminacy will show the number of additional equations that are going to solve the system. And this kinematic indeterminacy shows the number of unknown joint deformations. So this talk about the forces, and this talk about the joint deformations. And external, this degree of static indeterminacy, as we know that it is related to external indeterminacy and internal indeterminacy. So external indeterminacy will talk about the support system of the structure, that means reactions part, whereas internal indeterminacy will be related to the internal stresses in the members of the structure. So that means it will be related to the member forces. So this is all about the difference between your static and kinematic indeterminacy. Now coming to this slide. So this we just talk about some types of the supports and how many the unknown reaction components are there for this support and what is the degree of kinematic indeterminacy. Now coming to this free end support, as it is a free end, there will be no reaction component. But whereas coming to the kinematic indeterminacy, that is related to the movements of the joint. So free end, it is going to be free in all the three directions. So it is a degree of kinematic indeterminacy will be 3. Whereas coming to the simply support or roller end, we just consider. So for this, you are going to have only one upward reaction. So that means the reaction number of unknown reaction components will be 1. Whereas it is going to be the degree of kinematic indeterminacy here will be 2 for this roller support. And whereas coming to this hinge support, so here you are having 2 reactions at the hinge. So one is horizontal and another is vertical. So it is free to rotate actually. So therefore the kinematic indeterminacy here will be theta. And whereas delta B, delta A will be 0 at this support. And whereas coming to the fixed support, so here for this fixity condition, we are going to develop 3 internal stress resultants, that is horizontal, vertical, and moment. Therefore, the unknown reaction components here are 3, whereas the degree of kinematic indeterminacy will be 0. Why? Because it is restrained in all directions. Therefore, it doesn't have any rotation and it doesn't have any translation. So here the kinematic indeterminacy will be 0. Now coming to the degree of indeterminacy, for a beams, I just taken an example of proper cantilever beam. So degree of static indeterminacy when we calculate for this, so this is a proper cantilever. So number of reactions for this fixed support will be 3 and the number of reactions for this roller support will be 1. So therefore total reaction components are 4. Therefore the degree of static equilibrium, static indeterminacy is number of reaction components minus static equilibrium conditions. So static equilibrium conditions here are 3. Therefore, it is 4 minus 3 and the degree of static indeterminacy will be 1. Whereas coming to the degree of kinematic indeterminacy, so here we have taken a proper cantilever beam. So for this proper cantilever beam, if you just observe, so for this fixed support, there will be no rotation and there will be no translation. Whereas coming to this B support, as it is a roller support, here the displacement will be 0, but here the rotation is going to occur. Therefore, the kinematic indeterminacy here will be delta B. Sorry, theta B. So now coming to the next slide. So it is the degree of static indeterminacy for a pin jointed plane frame. Example. So to get the pin jointed, so now what we are going to see is generally there are J joints in a pin jointed plane frame. So for 3 members, we require 3 joints should be there. So that means it is going to form a basic triangle. So 3 joints and 3 members. So it is a pin jointed plane frame. So now we require 2 more members for connecting another joint. So for suppose if you just take another joint here, I'm taking a D as another joint. So to join another 2 members, so we require 1 joint for the already formed triangle. So here the triangle is already formed. So to join another 2 members, 1 joint is required. So this is a D joint. Now I'm joining these 2 members to this already formed triangle. Now what is going to happen is, so now the number of members that are going to be connected to the remaining J minus 3 joints will be 2 into j minus 3. Okay. So here we can just see, therefore the total number of members that are going to be there in this pin jointed plane frame will be given by m is equal to 2 into j minus 3 plus 3. So here plus 3 is nothing but the already formed members. This 2 into j minus 3 are nothing but already there are 4 joints are there. So 4 minus 3, that is 1 joint. So for this 1 joint, 2 members are required. So 2 into j minus 3 are the members that are going to be formed to connect this joint. Therefore, the total members will be 2 into j minus 3 plus this 3 members. So total members are 2j minus 3. So m is equal to 2j minus 3. So this is the m means members, j means the joints. This is the equation you are going to use for degree of static indeterminacy. So if both are equal, then it is determinate. If both are not equal, so then it will be a indeterminate to some degree. Now, if you just consider an example, degree of static indeterminacy will be related to external indeterminacy and internal indeterminacy summation. If you just consider this pin jointed truss, so here external indeterminacy will be at this hinge support, you are going to have 2 reactions. Again, at this hinge also 2, so total 4. So 3 will be equilibrium equations, that is 4 minus 3, it will be 1. Now degree of internal indeterminacy will be equal to m minus 2j minus 3. So here total members are 6 members are there and joints are 1, 2, 3 and 4 joints are there. So total internal indeterminacy will be 1. So now total degree of static indeterminacy will be internal plus external, that is 1 plus 1, 2. So therefore this truss is total degree of static indeterminacy for this truss will be 2. Now, if you just consider another one, that is for rigid jointed plane frame, how to find the degree of static indeterminacy. So coming to the first step, so generally if you cut any section, if a section is cut through a beam, okay, for a frame, if you just consider, if you cut a section through a beam, then there will be a 3 resultants will be there, stress resultants. One will be your axial force, that is your horizontal direction. Another is shearing force, that will be your vertical direction. Another will be moment will be released. Now, these stress resultants can be found by using equilibrium conditions, that is sigma fx, sigma fy, and moment summation of the moment will be equal to 0. Now, if m is the number of members in a frame, if you just consider, then unknowns will be equal to 3 times of your number of members, that is 3m. Now, if R is the number of independent independent components of your reaction, then the total unknowns will be equal to 3m plus R. And to obtain the equilibrium equations, we have to consider at each joint as we have to considering each joint as a free body. I mean, to get your equilibrium equations by considering each joint as a free body. Now, J means it denotes the number of joints, which includes the points of reactions. So, therefore, the number of equilibrium equations will be 3J. So, therefore, the total degree of static indeterminacy will be equal to 3 times of your members plus R will be your reaction components. In that, you are going to subtract 3J, that is nothing but your number of joints, which includes the points of your reaction. So that means the total degree of static indeterminacy will be 3m plus R minus 3J. So for this degree of static indeterminacy, just we take an example of a single story first. So now here we can have one end as a fixed and another end is a roller. So here ds is 3m plus R minus 3J. So members here are 3 and reaction components here are 4 and joints here are 4. So total you are having the degree of static indeterminacy to be 1. Now consider another example. So which is of figure B. So this is a single story frame. which is having two ends to be hinged. So here the degree of static indeterminacy equation is here, this one, and total members are 3, and the reactions are 4, and the joints here are again 4. So again it is static indeterminacy is 1. Now if you just consider a multi-story frame, so here you can just consider members. So the members here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, 15. So here the members are 15, and your reaction components are, for fixed support you are having 3. So total 3 are there, that is 9. And joints, if you consider 1, 2, 3, 4. So total joints of 12 joints are there. So this will be indeterminacy to 18. So next, coming to the next one. So degree of kinematic indeterminacy for trusses. So if you just consider the truss for a pin jointed frames, for the plane frames, the equation is 2j minus E, and for space frames, it is 3j minus E. So where j is nothing but your joints, and here 2 for the plane frames is nothing but for pin jointed, at the joint you are going to have 2 unknowns only, horizontal and vertical. So that is why we are going to write 2 into j. Minus E is nothing but your compatibility equations. So that we are going to solve by existing equations. Here for space frames, in 3 directions, you are going to have 3. So at each joint, you are going to have 3 displacements. So it is 3j minus E. So this is the thing. Now, for example, this truss, if you just consider pin jointed truss. So here the joints are 1, 2, 3, 4, 5, 6. E here is at hinge support, you are having 2, and at the roller support, you are having 1. So total it is 3 compatibility conditions are there. So for these 3 compatibility conditions, so your dk will be equal to 9. Now coming to the next one, that is degree of kinematic indeterminacy for a rigid jointed frame, if you consider. So for plane frames, it is 3j minus E, and for rigid space frames, it is 6j minus E. So now if j is the number of joints and E is the number of compatibility conditions. Now if you just consider this multi-story frame, rigid jointed plane frame. So total joints are 12, and compatibility conditions for each fixed support is 3. So total 3 supports are there. So 3 into 3 it is 9. Therefore the degree of kinematic indeterminacy here is 27. So this is the total static kinematic indeterminacies for all the beams, frames, and trusses. So these are the textbooks and references. These are the reference links. Thank you.